Yesterday we talked about circles. Today we are going to move on and talk about volume. I see Sean sneakily left me with the three-dimensional shapes. I know he likes to avoid having to draw them, so I'm sure that was part of his plan. But for those of you that are confused, my name is Mike. I normally do social studies and science. But when we're in person, I also do a math class, but we just haven't been doing 2 math classes online. But Sean will be back on Monday. He just has a meeting that he has to attend today and tomorrow, and he'll be back doing math class on Monday. So let's go ahead and get started. And today we're going to do the first half, the first chunk of the volume stuff. And tomorrow we will finish up volume, hopefully. So today I just want to talk about 3 different shapes. We're going to talk about rectangular prisms, cubes, and cylinders, okay? And that's it. So we'll talk about what volume is briefly. We'll talk about the various formulas for solving for volume, and then we'll look at maybe some practice type questions, or at least do some examples up on the whiteboard. So, if you've been in math class recently at all, we know, when we started with geometry, when we are measuring things, we kind of start with perimeter, which is just a one-dimensional measurement of the outside of a shape, right? Then we have area, which is measuring the 2-dimensional space inside of an object, or the space an object takes up. So volume is just the next kind of evolution. Volume looks at 3-dimensional objects and says how much 3-dimensional space does an object take up. So like a rectangular prism, like a book, or a cylinder, like a thermos, or a cube, like I don't have an example of a cube, but a dice, right? Or something. The difference between a cube and a rectangular prism is simply that all the sides of a cube are equal, right? Essentially like a 3-dimensional square. But when we're solving volume, whatever is easier for you, if you look down here at the different formulas, so again, you get the formula sheet on the test. You don't have to worry about memorizing these formulas. You just need to know how to use them, right? But what I was going to say is, if it's easier for you, you can use the same formula to solve for a cube and a rectangular prism, right? Now, you can't do an edge cube to find prism, because that won't work, because a prism is different lengths, widths, and heights. But you can use this one formula, which is area of the base times the height, and that will figure out any rectangular prism or cube. So it's kind of up to you, right? You'll get both formulas on the test, okay? And so down here are the formulas. You're not going to get them written out like this, so don't get too used to looking at them in words like this, because on the paper sheet of formulas that you get, you don't get them spelled out for you like that. You'll see these over here, where you have the symbols and the letters, okay? So it's just your job to know what the symbols and letters and numbers mean, okay? So again, we're just going to run through these first 3, do a couple practice questions, and kind of make sure that we can solve them on our own, and then kind of go from there. So rectangular prism is base times height. I wish it would just say length times width times height. And if you want to remember it that way, great. You probably won't see it that way on the formula sheet. That's the easiest way I like to remember formulas for area of a square or a rectangular prism, is just take the length, multiply it by the width, multiply it by the height. For whatever reason, they like to use this uppercase B, which stands for area of the base, or the bottom of the rectangle, right? And that's just a fancy way of saying length times width. Length times width does equal the area of the base. They just phrase it. So again, I know Sean's not a big fan of the uppercase B and the area of the base thing, and neither am I, but I mention it because that's what the GED likes to use for whatever dumb reason. All right, so enough of me blabbing on. Let's look at a couple examples. So I'll look through these examples in the book, just kind of briefly so you can kind of get an idea of what a question might look like, but then we'll pull up the whiteboard and I'll just draw up some shapes and we'll solve for the volumes of it. Sound okay? Okay. So while we're doing that, I'm just going to pull up these pages in my book so I have it in front of me. Okay. So example 1 deals with a cardboard box. Okay. And it says the box has the dimensions shown in the diagram. What is the volume of the box in cubic feet? So don't be thrown off. When it says cubic feet, that just means when you measure volume, just like with area where you're measuring in square feet or square units, right? Volume, because it's three-dimensional, is measured in cubic units. Or in this example, it's cubic feet, right? So that's all it means. So if we find the length and the width, right? Doesn't matter which one you call which, right? You could call the length width and the length 4, the width 5, or vice versa. It doesn't matter. So if we do 4 times 5, 20. 20 times the height, which is 3, comes out to 60 cubic feet. Pretty straightforward. So example 2 talks about a cube, and notice it uses the different formulas. So this one up here uses area of the base times height, or length times width times height, and we just do 4 times 5 times 3. Down here, example 2 says a wood block measures 2 inches per edge. What is the volume of the block? In other words, every one of those sides is 2 inches long. And it says use the formula V equals e to the third. So that's the formula for volume of a cube, where you take the length of one side, which was 2, because every side is 2, guess what? The length is 2, the width is 2, and the height is 2. That's why it says to do 2 to the third power. Not 2 times 3, 2 times 2 times 2. It comes out to 8 cubic feet. So, long story short, and I feel like I'm kind of throwing a lot out there, and of course this would be better if we were all in person, but we just kind of have to go with it. Hopefully that makes sense, and you can see why a cube formula is listed this way. But really, if you just want to think of it like length times width times height and ignore this, that's fine, right? You did 2 times 2 times 2. You're going to get 8, just like you would if you use this formula. Okay. So let's look at the last example that deals with probably the most confusing of the 3, and just because it's circular in nature, and that would be a cylinder. Okay? So example 3 says a storage tank has a radius of 1.5 meters and a height of 3 meters. What is the volume of the tank to the nearest cubic meter? So first, we didn't talk about the formula for volume of a cylinder. So remember, for those of you that were in class yesterday when we talked about circles, the formula for area of a circle is pi times radius squared. We have a circle. You can find the area of that circle by doing pi times the radius for the second power. And if we want to find the volume of a cylinder, all we do is take that and multiply it by how tall the cylinder is, the height, and that gives us the volume. So again, those of you that don't remember, for simplicity's sake, we're just going to use pi as 3.14. And it's not exactly 3.14. It's a decimal that goes on forever. And pi represents, or the way that number comes about and where pi comes from, is it is the ratio between the distance around a circle and the distance across it. No matter how big or small the circle is, if you take the circumference, the distance around, and divide it by the distance across it, or the diameter, you're going to get 3.14 blah, 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 every time, no matter what. So that's where that number comes from. You don't need to remember that, just so you know, right? So we're going to plug in. If we want to find the volume of this particular cylinder, first we're going to substitute 3.14 for pi. Then we have to find the radius. Again, remember, the diameter of a circle would be all the way across the circle through the middle point, right? The radius of the circle is just from the center to the outside. So in other words, half of the diameter, okay? So in this case, they tell us that the radius of this tank is 1.5 meters. So all we have to do is plug in 1.5 and make sure we square it. And again, that's not times 2. Anything squared times itself. So 3.14 times 1.5 squared times our height, which is 3. So if you have a calculator, you can plug all that in, right, in one shot. But be careful, though. Make sure that you're not multiplying 3.14 times 1.5 before we square. Remember, order of operations, we always do exponents before multiplication. Okay? So 1.5 squared, and I know the answer is right there in front of me. I'm just doing it for the sake of doing it. 1.5 squared comes out to 2.25. I'm going to do that times 3.14 times 3, and I get 21.195 cubic meters, right? Which is what they get in the book, right? So hopefully that makes sense. I know that was kind of a quick run through, but I want to actually do some of these and have you do some as well. Okay, so I'm going to stop and pull up the whiteboard. I have no idea how drawing three-dimensional objects is going to go. So let's find out. All right, so let's start with a rectangular prism. Oh, I don't like green. Let's try that again. I was hoping they were going to have three-dimensional objects on here, but I'm just going to have to do it myself. Okay, not perfect, but good enough. So let's say that this box has a length of 8 inches, a width of 3 inches, and height of 6. Okay? So again, if we want to find the volume of this rectangular prism or this box, all we have to do is multiply them all together. Length times width times height. And remember, big B is the area of the base. And so just to show you what that is, if I was to draw this in all the way, right? Bear with me, my lines aren't straight, I know, but I'm just kind of winging it, right? What we're talking about would be this section here, right? I can't fully color it in, but this bottom section here, right? What would be the area of that? So that's where the big B comes from. But again, you just want to remember length times width times height. Great. So to solve for the volume of this, we would just do 8 times 3 times 6. 144. 144 cubic inches would be our answer, right? So our volume would be 144 inches, and then it would be like to the third power. I can't do it I'm not savvy enough to remember how to do the little superscript 3, but you get the idea. Okay, so that's pretty easy, pretty straightforward. Let's look at a cube just to make sure we're feeling good. I want to make sure we get to some harder questions because unfortunately for you, you're not going to get questions this easy on the test. You're not going to get, here's a shape, here's the length, the width, and the height, find the volume. Right? They're going to be a little bit trickier than that. They're going to be worded a little bit differently. So I don't want you to expect something this easy. But again, I wanted to at least make sure that we understand before I worry about getting too complicated. I'm going to try to pretend like I'm drawing a cube. Pretend all these sides are equal. Oh. Okay. So let's say this is a cube with a side length of 8 centimeters. Okay. So you might get something like this where they say the following shape is a cube, and then they don't say anything else, right? They don't give you the fact that the width is 8 and the height is 8. They just tell you it's a cube, and you are left to assume that you know every one of these sides is going to be 8 centimeters. So you can figure this out however you like. If you want to use this formula, right? Edge to the third power, or edge times edge. I really shouldn't use x, right? That's essentially what you're doing. You're taking the side length of a cube and multiplying it by itself 3 times, or you could still think of it as length times width times height. Either way, you're doing 8 times 8 times 8, which comes out to what? 8 times 8 times 8. Yeah, 512 cubic centimeters. Okay, so let's pause there. I'm going to put on I'm going to go back to the book. So bear with all my jumping around. And like I mentioned yesterday to whoever was in class, I'm still kind of figuring out how best to do math on the computer. So bear with all my jumping around. And I know Sean does it much differently than me, but that's just what you get with me and Sean, for those of you that know both of us. Okay, so here's an example. I wanted to pull this up because this is, and hopefully everyone can see this. If you can't, please let me know. But hopefully everyone can see this question here, number 7. So the reason I pull this up is because this is more like what you would expect to see on the test for a question that deals with volume, right? So the question says, a rectangular box with a volume of 80 cubic feet has the length and width shown in the drawing. What is the height? Okay. So this is tricky because they don't ask you to find volume, right? They tell you what the volume is. They say the volume is 80 cubic feet. And they tell you the length and the width are 4. Okay? So don't assume, first of all, don't assume it's a cube just because these numbers are the same. They tell us it's a rectangular box, and also 4 isn't one of the options. Because what are we trying to find here? We're not trying to find the volume. We're trying to find what the missing height is, or the value that's missing. So you could do it a couple ways. All right, and I'm just going to kind of talk through it, and then I can pull up the whiteboard and maybe show you an example of something like this. But just think about and try to remember, what is the formula for volume of a rectangular prism? Length times width times height. So with that said, what do we know? We know that 4 times whatever our missing number is has to equal what? It has to equal 80. Okay, so I'll pull up the whiteboard and show you kind of an algebraic way to solve this, but you could also just kind of guess and check by looking at your answer choices. Right? If I just pluck a number out of thin air, let's say I pick 10, because the math is easy. Okay, if 10 is the right answer, then 4 times 4 times 10 is going to equal 80. What is 4 times 4? 4 times 4 is 16. 16 times 10 is 160, right? Is 160 the same as 80? No. So if 10 is too big, because 10 generates a volume that's too big. So by process of elimination, we know 16 and 20 are also going to be too big because they're bigger than 10, right? So we've just found the answer. The answer is 5. That's the only one left that makes any sense. And sure enough, if we do 4 times 4 times 5, we end up with a volume of 80, okay? That makes sense? So let me pull the whiteboard back up and give you one similar to that. Let's see. Okay, so let me draw up a new, and then we'll spend the last few times or few minutes going over a cylinder. All right, so here's my box, right? Not perfect. Okay. Let's say this box has a length of 21 feet. Let's call it a huge box, like a room. Okay. And let's say it has a height of 14 feet. And we are trying to figure out what the width is. So let's say I'm just going to make up a number. Give me just a second. I'm winging it on the fly here. This is a big room. Okay, so this room has a length of 21 feet. In other words, it's 21 feet long, 14 feet high. What is the width? If I tell you that the volume is 4,704 cubic feet. Okay, so guessing and checking would be a lot harder if, for this situation, there's no multiple choices, right? So how do we solve it? Well, one way we could do it, and again, guessing and checking would eventually get you to the right answer. But if you don't have multiple choices, which sometimes you won't, then you're left with just plucking numbers out of thin air and kind of working from there. But a faster way to do it would be to set up an equation. We know that volume of a rectangular prism equals length times width times height, right? So let's take what we know and plug it into this formula and solve it like an algebra problem. Okay? I know some of you don't love algebra, but sometimes it's the easiest way to solve things. So if I make a problem that looks like this, 4,704 is equal to, that's my volume, I've just taken this and plugged it in for V. Okay, we know the length. The length is 21. So 4,704 is going to be equal 21 times whatever our width is, times our height, which is 14. Okay, so for those of you that have gone through some algebra or feel pretty comfortable, how do we solve for that unknown variable? How do we figure out what y is? Okay, well, the first step, or maybe the next step, would be combine what we can. In other words, we can do 21 times 14 and figure out what that is. So 4,704 is equal to, I'm going to do 21 times 14 in my calculator, and I get 294. you are kind of following along. I realize I might be going kind of too quickly through this, so hopefully this is making sense. So 294 is equal to 21 times 14. So I'm going to rewrite it like this. 4,704 is equal to 294 times W. Okay, and for those of you that have gone through algebra, the last step to figuring out what this number is, other than just guessing and checking, we could pluck a number out of thin air and we could eventually find the right number. But the easier thing would be to solve for W. We do the opposite function of what's being done, right? So what is the opposite of multiplication? Division. So we're going to divide both sides of the equation by 294. 294 divided by itself comes out to just W, right? Because 294 divided by 294 is 1. 1 times W is just W. So we've eliminated the 294 on this side, which is the point of doing the opposite. Now we have to do 4,704 divided by 294, and we should get our answer. 4,704 divided by 294, and that comes out to 16 feet. And always with geometry, check your answer, right? If we've done the math correctly, then we should be able to type in 21 times 16 times 14, and it should come out to 4,704. It does. So let's stop there. I know we didn't get to cylinder, but that's okay. We can do cylinder tomorrow. I just hopefully want to make sure that makes sense. And especially this last question where you're asked to solve for kind of missing components. That's the type of question I would expect to get on area questions, volume questions, and then eventually when we get to surface area, those are the types of questions you're going to get, right? Are ones that are a little bit tricky. So again, hopefully that was helpful. I'll be back for one more math class tomorrow, and then Sean will be back to normal on Monday. I do social studies at 11:15 and science at 1:15 if anybody needs help with those subjects. And with that said, I will let everybody go and see you the next time I see you. All right. Have a good one, everybody. Thanks.